Good afternoon. On behalf of the director of the Ramón Areces Foundation, Mr. Raimundo Pérez Hernández, let me give you a warm welcome to this foundation and to this conference. Let me introduce myself. My name is Daniel Santin. I'm professor of economics at the Complutense University of Madrid, and I'm also in charge of organizing some of the activities sponsored by the foundation. Today's conference is entitled The Economics of the Global Energy Challenge and will be given by Michael Greenstone, who is professor at the University of Chicago. In addition, Raúl Bajo, professor at the Navarra Center of International Development from the University of Navarre, will introduce Professor Greenstone and moderate questions from the audience. Thank you very much to both for having accepted to be here with us. This event will be in English. However, since one of the priorities of the Foundation is to foster the use of the Spanish language in science, let me do part of this introduction in English. In Spanish. Sorry. Bien, en primer lugar, quiero agradecerles a...
Let me begin by saying thank you all very much, those of you who have traveled to the Ramón Areces to participate in this afternoon's session, because, of course, without your good selves, this event would simply not be possible. Secondly, let me say thank you to the University of Navarre, the School of Economics, and the National Center of International Development. I'd like to say thank you, as I say, for their engagement and commitment. It is thanks to them that today at the Ramón Areces Foundation, a workshop has taken place which is called Economics of Climate Change and Environmental Sustainability, which has benefited from outstanding speakers and from the contributions of 50 professors from different entities. For those of you who are not familiar with the objectives of the Areces Foundation, let me share with you that the Fundación Ramón Areces aims at disseminating excellent science in Spain. The foundation divides its activity into three areas: social sciences, material sciences. We today are, of course, addressing social sciences, and the humanities. Within the area of the social sciences, which basically focuses on economics, the foundation carries out many different activities, and among them I would underscore a number of them. Our sessions are held with the aim of participating with top-notch students. Their master's, their PhD studies are financed by us. They work on PhD studies. There is assistance and subsidies to the under 40 researchers. And I would also call your attention to some of the strategic alliances we have signed, among them with MIT, the LSE, Oxford University. These are the ones that first come to mind. And I would also underscore other activities to disseminate science, and that would be the excellent results of the papers in scientific publications and civil society, so that indeed information of the best possible quality is available to all. For those of you who are interested in what the foundation does, let me just recommend that you visit our website. You will be seeing that in upcoming weeks we are going to have other interesting sessions, and of course you can also use our YouTube channel. And without further ado, I'm going to give the floor to Professor Raúl Bajo, who is going to introduce our speaker. And I think that what we want to do now is enjoy these two speakers.
Introduction, and again, thank you so much for the hosting us in this today's workshop, which was very interesting. And also it's going to be very interesting, the talk by Michael Greenstone. And I'm actually honored to present Professor Greenstone here today to all of you. The conference is going to be in English, but let me switch to Spanish to introduce the main things I want to say about Professor Greenstone. So, buenas tardes.
So thank you very much. It's an honor for me to introduce to you. It is an honor with a capital H, I would add, to introduce Professor Greenstone this afternoon. Michael Greenstone is the Milton Friedman Distinguished Service Professor in Economics at the University of Chicago. He formerly taught at MIT, and he studied at Princeton. He there studied economics. That's where he earned his PhD. And it's a challenge for me, actually, to speak briefly about Professor Greenstone because he's done very many things. He's director and founder of the Institute for Climate and Sustainable Growth at the University of Chicago, and also director of the Energy Policy Institute, the EPIC. His research is very important in the field of economics, especially vis-a-vis the environment, climate, energy. Very technical, very good, but he also has a public policy angle. And he, for instance, was chief economist of President Obama's administration. He was chief economist on the Council of Economic Advisors. His CV is very long, but I think that what we want to do is hear him. Again, thank you very much, Professor Greenstone, for being with us. And let me please ask you to come up here. And, of course, thank you so very much to the Foundation for having made this event possible and for having hosted us today. Professor Greenstone.
Thank you for that excellent introduction. Mi español es muy pobre, entonces comprendo un poquito.
He apologizes for not speaking very fluent Spanish and introduces himself.
Today, and I'm happy to talk with you about what I'm going to call the economics of the global energy challenge. And I think it takes 4 seconds of Googling to see climate change has arrived. There's pictures of extreme heat. There's reports from South Asia of days that are 45 and 50 degrees C. There's evidence of more powerful storms and more frequent wildfires. Los Angeles in the United States had very horrific wildfires just last year. But what I want to argue, and this will be the thesis of my talk, is that it's a mistake, I'll say it provocatively, it's a mistake to think about climate change. And instead, what we should be thinking about is the global energy challenge. And so let me explain how I define the global energy challenge. The global energy challenge is very well captured in this picture. This picture is a little dated. It's from Beijing about a decade ago. And the global energy challenge has at its core 3 features. The first is the need for inexpensive and reliable energy. And if you look at this picture, you can feel it. The guy, China has, maybe the greatest economic event of the last several centuries is the increase in living standards in China just in the last few decades. And so the guy in the cab was probably on a bike not very long ago. The picture's a decade old. The guy in the bike is probably in a car now. And all of that economic growth was unlocked by access to inexpensive and reliable energy sources. So every society is very, very focused on how to have inexpensive and reliable energy in the name of advancing living standards. The second goal of the global energy challenge, I think, is also maybe even more evident in this picture. The fossil fuels that unlocked all that economic growth in China are super evident in the picture. It's the middle of the day. You can't see the sun. The guy on the bike has on goggles. This is pre-COVID. He has on a mask. He's super aware that a byproduct, or as we say in economics, an externality, an unintended or unwanted outcome of using all that energy for the economic growth is this horrible air pollution. And that air pollution causes people to lead shorter and sicker lives. So that's the second leg of the stool, which is how do you have, the first is the inexpensive, reliable energy. The second is how do you not make yourself sick and lead shorter and sicker lives through the use of the energy. And then the third leg, of course, is climate change. And the very same fossil fuels that have unlocked all that economic growth and are causing this terrible air pollution are also increasing the odds of disruptive climate change. And so, to come back to my thesis, I think what the world has in front of it is not a need to minimize climate change. It has a need to find a balance between these three goals, which are deeply interrelated. And so that's my thesis, and I will try to make this come to life a little bit more as we go along. And so I'm calling that the global energy challenge. And to exclusively focus on climate change misses that when we're choosing our energy sources, be it coal or oil or natural gas or renewables or nuclear, we're choosing a bundle of three things. The price we're going to pay for that energy, the air pollution we're going to do to ourselves, and the degree of climate change that we're going to have. And the reason that I was invited here today is because there's no single energy source that is the cheapest, least polluting, and has the least carbon content. If there were, I wouldn't have been invited and we wouldn't have had this conference today. And so all of these things affect human well-being, and the challenge for societies, every society, Madrid, Spain, the United States, Pakistan, India, is to find the balance that works for them among each of those goals. So I will begin. I love figures or graphs, and I'm going to have 7 facts that I think define this global energy challenge. Some of them will be familiar, maybe all of them will be familiar to you. Hopefully I will illustrate them in a new way. And then I'll talk about, I used to end the talk there, but my children told me that it was way too gloomy, and so now I will end with some solutions. Okay, so the first is, and I think everyone kind of instinctually knows this, it was in that picture, is that energy consumption is critical for living standards. So here on the horizontal axis, we have total energy consumption, and on the vertical axis, we've got, think of it as GDP per capita. And there's an incredibly tight relationship between those two. And so really, if you wanted to make it very sharp, we just don't have any examples of societies becoming wealthy without using lots and lots of energy. So that's almost, you should treat that as a fixed point. The second is that energy consumption is low in many highly populated areas of the world. And in fact, I think surprisingly low. So in the United States, this is electricity consumption. Per capita electricity consumption is probably about 13,000, maybe somewhere between 13 and 15,000 kilowatt hours per person every year. In China, it's probably about 6,000, maybe 5,500. I put this in here for this talk. Spain has a very favorable climate, so it's maybe 4,000 or 5,000. India, which does not have a very favorable climate, per capita electricity consumption is about 1,200, so they're like a tenth of what the United States is. And then I do a lot of work in a state in India called Bihar. Bihar, electricity consumption there is about 350 kilowatt hours per person per year. So they're like off relative to the United States by like a factor of 50. It's a totally unacceptable state of affairs if you're in Bihar. You know, these are numbers, but encoded in those numbers are people leading shorter and sicker lives, people doing things with their bodies, moving things that we would have machines do in developed countries, getting injured doing that. It's not an okay way to live. And they're going to be, and they are, rightly, deeply focused on increasing energy consumption and increasing living standards. Okay. So fact 3 kind of follows almost that energy consumption, if we were to go forward, in emerging economies is projected to grow. And in fact, all of the world's growth in the coming decades is projected to come from today's emerging economies. So their global energy demand is set to grow by about 15% by 2050. These numbers probably predate some revisions due to AI, but 100% of that growth is going to come from, or maybe more than 100% of that growth is going to come from today's emerging or developing countries, especially in Asia. Okay, so that's all well and fine, the first three facts. I don't think there's anything very controversial. Now we'll start to get to some of the tension that exists inside the global energy challenge. So what fuels are we going to use? And the short answer, and I know Spain is a great leader in this space, but the short answer is that the world is going to continue to remain very focused on fossil fuels, and they're going to remain the dominant, these are the standard projections, remain the dominant source of energy. And so here I have global energy consumption. The blue bars are fossil fuels, and so to be precise, you should think of fossil fuels as coal, oil, and natural gas. And then the green bars are the non-fossils. It's primarily nuclear and renewables. In some places, it's hydro. And it's absolutely true that there's been great advances, but you should think of it as, I've heard this analogy recently, it's like stacking. It's not that the renewables look like they're going to drive the fossils out. Kind of the fossil consumption looks like it's going to remain relatively constant, and we're going to have increases in these non-fossil energy sources. And that's great that the share is going down, but I will state the obvious here. The planet doesn't care about the share. The planet only cares about the total amount of CO2 in the atmosphere. And so this would suggest that the atmosphere is going to continue to be polluted with CO2. Now, so you might ask, well, why is this the case? There's a lot of headlines about renewables. Why is it that we're going to continue to be so heavily reliant? This figure is a little bit complicated to explain, but let's see if I can do it here. So on the horizontal, so this is comparing the lifetime costs of an electric vehicle. Admittedly, this probably doesn't have the Chinese electric vehicles, which are cheaper. And on the horizontal axis, we've got the cost of batteries. That's the primary costs of electric vehicles. And on the vertical axis, we've got the price of a barrel of oil. And the red line is combinations of the price of batteries and the price of barrel of oil, where the lifetime cost of owning an electric vehicle versus an internal combustion engine are roughly constant. So if we were to take today's, or this is December's, so the price is a little lower now, December's oil price, that was about $69 a barrel, that would require that batteries have a break-even price of $63. That's less than, the current price is more than double that. You could see if, according to the US Department of Energy, if we were able to reduce batteries to $75, then we would need a price of oil of about 79 bucks. And so the main thing is just see that the world is largely, minus subsidies, in that kind of pink or salmon area. And there's going to continue to be lots of reliance on internal combustion engine cars. Again, how we think about the Chinese cars and their lower costs would complicate this. So that's in transportation. The story in power is maybe clearer. And so this is going to differ depending on where you are in the world. But this is the levelized cost of producing a kilowatt hour of electricity in the United States. As many of you probably know, the United States is awash in natural gas. We're now trying to export it everywhere. And so if you were to build a new plant, a kilowatt hour of electricity that came, a combined cycle natural gas plant, that came from natural gas is about 4.2 cents, maybe 4.3 cents. And so what I'm going to do now is I'm going to show you what the cost is from using alternative sources. But I'm going to draw this dashed horizontal line there, just so you can keep your eyes on what's really kind of the outside good, what everyone has to beat. And so here, this is a coal plant. This is a coal plant with all the controls that are required in the United States. Without those controls, it would be a formidable competitor with natural gas. Then there's a nuclear plant, and then there's coal with CCS, which is they would capture the carbon out of the stack. That's like a theoretical plant. It doesn't really exist. What I want you to take away is natural gas is the clear winner among the existing technologies. It's at about 4 cents, as I said, about 4 cents a kilowatt hour. And now I'm going to show you what I would call Frankenstein plants. So these are solar, wind onshore, wind offshore, and I'm going to repeat it. Why am I doing it twice? And why did I call them Frankenstein plants? The problem with solar and wind is that the sun doesn't shine all the time and the wind doesn't blow all the time. So if you're going to build those things, you have to have something to back them up, and those things cost money. So here's when you have a natural gas backup, and you can see it. All of these technologies end up being more expensive than just using a combined cycle natural gas plant. And of course, these aren't carbon-free anyway, because the natural gas backup is operating a lot of the time. In the U.S., a solar plant is operating about a quarter of the time, so you could fill that rest in with natural gas plant, and wind plants are operating about a third of the time. If instead you want to have a completely green power sector, you could use batteries. Batteries, there's been enormous progress in batteries, but you can see those are still more expensive than even with a natural gas backup. And so, what this is saying is in the power sector, the fossil fuels without a carbon price, which the EU has, but most parts of the world don't have, you end up with a setting where the market is going to will lead people to choose to continue to use the fossil fuels. And so that's why the fossil fuels continue to remain dominant in the standard projections going forward. One popular theory for a while, I think it's less popular than it used to be, was, well, everyone understands we're going to run out of fossil fuels. On the planet, there's a finite amount. And so what I want to say, again, maybe somewhat provocatively, is there's not a finite amount of fossil fuels. And I know that sounds wrong on its face, but here, let me just show you the ratio of reserves to production. And this was in 1980, and it's for oil. And so that says that that ratio was about 30 in 1980. That would imply that we should have been out, and this is globally, we should have been out of petroleum by 2010, if my math right, 1980 plus 30. Instead, what happened? The ratio of reserves to production went up. So how is that possible? So the people who run the oil and gas companies are incredibly smart. And what this is saying is they're finding it faster than we're consuming it. So I think if the plan for not using fossil fuels is that we're going to run out, there's no evidence that that's going to be the case. The story is very similar for natural gas. There's so much coal, you can practically trip over it in many parts of the world, and we're never going to run out of that in any time, at least on any time scale that matters for climate. Okay, so that's, energy consumption is going to grow a lot. We know the countries it's going to grow in, and the world seems poised to continue to be heavily reliant on fossil fuels. Is that a problem? And so now I want to turn to what I described as the second and third legs of the stool that defines a global energy challenge. And so I'll start with fossil fuels increase air pollution, and that shortens lives. So again, in the wonky language of economics, you could think of this as an externality. That is, in particular, showing here there's about 6 billion people who live on the planet in places where the level of particulates air pollution exceeds the WHO, World Health Organization, standard for what would qualify as a safe level of particulate pollution. And you can see where they're located. A lot of them are in Asia, and relatively small numbers in the United States and other places. So how do we know what the consequences of long-run exposure to air pollution are? so if the world were run by academics, and thankfully that's not the case, academics would have run a randomized control trial where they might have taken the people on the right side of this room and put them in a bubble for their whole life and injected that bubble with lots of air pollution. The people on the left side would have randomly been in a different bubble and had low levels of air pollution. Thankfully, no university would ever allow that to happen. So instead, you have to look for something that resembles an experiment, that kind of randomized control trial I just described. And in economics, that's often called a natural experiment or quasi-experiment. And so I'm going to tell you here about a paper I wrote that tried to find a natural experiment for understanding what the impacts of long exposure to high levels of air pollution over one's lifetime. And so it's based on a policy that China had dating back to the planning period called the Huai River Winter Heating Policy. And so back in the planning period, China was much less wealthy than it is now, and they didn't have enough money to provide winter heating for everybody. And so they did what was a pretty arbitrary thing. They just drew a line across the middle of the country, and they said, if you live, I think this is going to work. Okay, yeah, excellent. If you live north of the line, we're going to give you free winter heating. So that is, we're going to build coal boilers and attach them to basically every building. And we're going to give you free coal from November 15th to March 15th. But if you live south of the line, you're like totally out of luck. No winter heating for you. And indeed, I've given a lecture at a university in Chengdu, which is kind of in the northern part of the south. They have pretty cold winters, in a room not quite as nice as this room, but similar. And all the students had on winter coats. That's just the way it is. Everyone was used to that. And so the idea of this paper is, and China had, by the way, very restricted migration until maybe a decade or 15 years ago. The idea of the paper is to compare people who are born just to the north of the line to people who are born just to the south of the line, knowing that they couldn't migrate, and see what happens to their rates of mortality and their life expectancy. So let's take a look. Oh, and so here's the obligatory picture from one of my Chinese co-authors. They didn't build power stations away from the city center. They had kind of small boilers attached to every building, and that's where the free coal was burned, and people use that to heat their homes. And you can see there's no air pollution control device on there. And the whole paper boils down to basically two figures. The first is, and so let's just get our bearings here. The zero line here you should think of the Huai River. That's the line that divided the north and south of China. And then each of these bubbles are 1 degree latitude displacements from that line. So this bubble are people who live 0 to 1 degree south. The next bubble is 1 to 2 degrees south. And then, okay, well, yeah, you get it. There. Those are people who live 0 to 1 degrees north, and then 1 to 2 degrees north. And the bubbles are proportional to the number of people who live in those zones. And so what you can see, it jumps off the figure, is right at the river, there's a huge jump in air pollution concentrations. It's worth about 40 micrograms per cubic meter. The south is also very heavily polluted as well, just not as much. They're at about 100 micrograms per cubic meter. This is a PM10. And just to the north is about 140. If you want a comparison, I should have looked up this morning. It's probably like 5 outside right now in Madrid. Madrid is very clean. So these are very, very high levels of pollution, but the comparison is going to be people who live just to the north versus people who live just to the south. So the second figure, which I'm sure you can have guessed what it's going to be, this is life expectancy. Again, you should think of this as the river, and then this is 0 to 1 degrees north, and that's 0 to 1 degrees south. And what's striking about the figure is that there's this sharp jump right at the river's edge, just as there was on air pollution. There is not a jump like that anywhere else in there, and it can test for that statistically. If you put the two together, and so, the people who were the intended beneficiaries of this policy, on average, are living about 3 years less, that is on the north side than on the south side. And if you put the two together, you can estimate what an extra 10 micrograms per cubic meter of PM10 is worth. In this case, it's about 3/4 of a year. So I thought that provided some evidence on what long-run exposure was, and I was shocked at how large it was, and I was shocked that people were not taking it more seriously. And so I think part of the problem is when you use units like micrograms per cubic meter, you're basically asking people to stop listening to you. And so what I did is I created something called the Air Quality Life Index. It's a web tool. You can go log onto it yourself. The page is there. And what it does is for about 50,000, it divides the world into about 50,000 squares, I think 10 by 10 kilometers, something like that. And you can look up the level of air pollution there. And then, since nobody knows what a microgram per cubic meter of air pollution is, it uses that study from China to convert that into the gain in life expectancy if that area were brought into compliance with either the WHO standards or the country's own standards. And so here you can see, this is, I've switched to PM 2.5, but you can see the parts of the world that are most polluted. This is in using 2022 data. If you go to the website, you can actually choose any year between 1998 and 2022. It comes from satellite data. And you can see Western Europe is very clean. Spain is clean. The United States is very clean. That would not have been true if we'd done that 4 or 5 decades ago. I'm from Chicago. There's very high concentrations of pollution then, much less so now. If you want to see what the gain in life expectancy that each of these parts of the world would achieve, that's also available on this website. And you can see that there's parts of the world, a lot of them in South Asia, where people would live 6 years longer if air pollution were brought into compliance with WHO standards. So since I'm here in Spain, I couldn't resist. So this is, so basically you can see almost all of Spain is in compliance or has air pollution concentrations lower than WHO standard. I don't know what that district or region is. Okay. But you can see it's very lightly colored yellow. If you went back in time in 1998, you can actually see the improvement. There was a lighter yellow in many places. And I think, I looked it up this morning, the average person was losing about half a year of life expectancy in 1998, and that's now maybe down to a quarter or less. And you can see what's going on there. Okay, Spain is not the average. Spain is a very clean place. If you took the average across the entire planet, the average person is losing about 2 years of life expectancy. And this is where I don't think we pay enough attention to air pollution. That's more, this didn't come through, but there's a red circle around it. That's more than the loss of life expectancy due to tobacco, more than alcohol, basically any other external threat to public health. And this is all summarized here. I find this shocking, but to each their own. Oh, there's the red line, okay. Okay, so that's the second leg of the stool. And then climate change is such a nasty problem that I decided it needed 2 facts. And so we'll start with fact 6. So the impacts of climate change are projected to be large but unequal. So let's begin. I think there is like climate doomerism, I think. And so I always think it's important to level set on exactly where we are. So this is global CO2 equivalent emissions. This is like CO2 and the other greenhouse gases. And you can see it's been going up pretty drastically since about 1990. And then, I don't know if it probably depends if you're a glass half full or half empty person. The black line is the projections. So you might have thought it was just going to keep going up. And so if you want to be a glass half full person, then you say, well, that's real progress, that we've broken the back of the upward trend, and you can see it start to go down. But in no sense are we on a path to net zero in 2050, 2040, or even 2100. This is kind of business as usual assumptions. And in fact, what I find so striking about this is actually emissions start to go down, but then they start to go up again. And the reason that they start to go up again is that there's like two forces that are in conflict with each other. There's the greening of the grid in a lot of parts of the world, and that's kind of spreading across the world in the background. But then there's also a massive increase in energy consumption that's coming. And a lot of that is coming in sub-Saharan Africa. And eventually, by 2050, 2060, that starts to overwhelm the greening of the existing energy sources. And that's why you see it start to go back up. And then the blue areas, by the way, of course, these are projections about the future, so we don't know exactly what's going to happen. But that you should think of that as like covering a 90% confidence interval. Okay, so that's emissions. Where are we on temperature change? And so here's the range, a 90% confidence interval for temperature change. We're kind of on a path to, by the end of the century, about 2.7 degrees C. And of course, it would continue to go up after the end of the century, since emissions are still increasing at the end of the century. And you can see the range is actually somewhere between about 2 degrees and a little bit less than 4 degrees. Now, here's like the good news thing. If we'd had that, if you had invited me here a decade ago, I would have had to put up what we thought the range was a decade ago, and so let me put that up. And what's striking is how much wider the range was. And of course, the center of that range was higher than it is now. But I really want to emphasize the enormous benefits of this kind of, let's call it, 4.5, 4 degrees and above not happening, which it looks like there's now a very small chance for that to happen. And that is really incredible in terms of human well-being, because the relationship between human well-being and temperature is what we would call very nonlinear. And so once you get out to those 4 or 5 degrees, that's where a lot of the really dangerous stuff lives. And so it's not that we don't have damages coming, we do, or that we already have them, but the nastiest stuff seems much less likely than it did maybe a decade ago. Okay, so I was interested in, so the climate scientists kind of stop here. And thankfully, for this foundation and other fellow travelers, there's a recognition that the climate scientists aren't economists. And although the climate scientists love to make economic predictions, you should ask a person on the street, I think, as much as you should ask a climate scientist. And so I thought, well, gosh, it would be good to know what that translates into in terms of human well-being. And so I helped start something called the Climate Impact Lab, which takes as its mission the development of estimates of what the economic damages from climate change will be. And we have a very bottoms-up approach where we try to get the estimates of, say, of the temperature-related mortality, the impacts on agriculture, the impacts on energy consumption, the impacts on workers, and then, of course, the coastal impacts from sea level rise and increased storm intensity. And so we add all that up, and this is pretty wonky. This is with one scenario on what might happen to emissions. You can see this is the range at the end of the century of damages with that, and then if we end up at a higher emission scenario, that range is greater. Let's not focus on the exact mean of that range. What I really want you to pay attention to is we don't actually know for sure, but this is giving you some sense of the range, accounting for that uncertainty around climate and accounting for our uncertainty around what the economic damages are going to be. I think it's useful. One problem that we have had as a profession or as a world is reporting what the impacts of climate change are going to be at the global average, but nobody lives at the global average. They live in Madrid, they live in Chicago, they live in very particular places. And so these are damage functions, which effectively tell you at different changes in the global average temperature, what will be the effect as a percentage of GDP, what will be the effect of climate change. And so we're kind of, if you want a rule of thumb, we're kind of headed towards 3 degrees. And I just highlighted, so these are for 25,000 regions around the world, and I just picked some that I think are especially interesting. It's absolutely worth noting that there are a bunch of places, there we go, where actually climate change is beneficial. You could think of that as like Norway, which has terrible winters, or Russia, or northern Canada. But when you add it all up, on average, it's the damages are positive. That is, they're negative. That is, they're going to make us worse off on average. But what is important is how different they are going to be in different places. And unlocking this, what economists call heterogeneity, or these differences across places, is important in understanding what the total damages are going to be and what people are going to have to do in those places to adapt. So I'll just skip some of the details here and just come to one metric of how unequal they're going to be, which is 10% of the world's population is projected to bear 60% of the damages. And you can see those are basically the red places where those damages. And why are they up in northern Canada? That's from the flooding. And there aren't any and sea level rise. There aren't any humans there, so it's a little misleading. But you should think of it as largely being in sub-Saharan Africa, important parts of Asia that are already hot and tend to already be poor, and the combination is very dangerous. So if you were to try and this is another thing that I think is a little surprising if you try and add it all up, the cost of an extra ton of CO2 that we put into the atmosphere, and I don't know what it is in Spain. In the United States, the average person is responsible for about 15 tons of CO2 per year. Every additional ton does about $170 of damages. What is striking, and it's encoded in this figure, but now summarized here, is that almost all of those damages are projected to occur outside the OECD. And so of that 173, 167 are projected to occur in the non-OECD countries. Those are the countries that we looked at earlier, have pretty low levels of energy consumption and pretty low levels of income. And the impacts in the OECD countries are pretty small. And that's because you got a balancing act going on, where the northern parts of the OECD are actually probably going to benefit slightly, at least at relatively low levels of temperature change. And the southern parts, there'll be some damages, probably in Spain, and the two kind of balance each other out such that almost all the world's damages are going to occur outside the OECD. I'm going to skip this. Okay, so if you wanted to look at the places that are expected to have the largest per capita damages from this climate impact lab work, here's a list of them in 2030. Here's a list of them in 2050, and here's at the end of the century. And you can just see from this list where those places are located. And again, I just want to keep coming back to is on average, there's big effects, But what's striking is how unequally they're distributed around the planet. Okay, so now I'm going to try and connect all the different parts of this lecture thesis, which is the seventh fact is that climate change has incredibly cruel arithmetic. Let me start with, let me say the cruel arithmetic of the global energy challenge. So let's just start with, here's emissions per capita today in the OECD countries versus the non-OECD. You can see the OECD countries, the average person is responsible for twice as many tons. This is say nothing about the history where the ratio is even greater. And then by the end of the century, it's still the case that the OECD countries on a per capita basis are emitting more. And so now I want you to think back to those non-OECD countries which have low levels of income and are largely in the bullseye of climate change, have high air pollution. And let's just take a look at what end of the century emissions are projected to be around the world. The blue bar are the OECD countries, and you can see that the world is seemingly headed to about 45 billion metric tons of CO2, and almost all of it will be from the non-OECD countries. And the horizontal dashed red line is the level of emissions that would be required at the end of the century if we were going to keep things to 2 degrees C. Which is a commonly cited goal. And so you can see, well, maybe the OECD would just, out of the goodness of its heart, go to net zero by the end of the century. If it did that, the world would still be stuck with the green bar. And so what I want you to take away here, like the pain of the global energy challenge, is that the very places that are desperate for more energy consumption, they're desperate to unlock higher living standards. They're desperate because they want their children to lead richer and fuller lives, now would have to be asked to reduce that green bar by at least 85%. And what does that mean to reduce that green bar? Well, you guys already saw that. That means buying more expensive energy that costs 2 or 3 times what continued use of fossil fuels costs. And so that's why I said at the start, I think to focus on climate change in isolation is a mistake. Humans weren't put on the planet to minimize climate change. They were put on the planet to maximize human well-being. And you run into this conflict with climate change. So let me try to summarize the argument, and then we'll go to some solutions. There are these 3 goals: access to inexpensive and reliable energy, preventing yourself from leading shorter and sicker lives due to air pollution, and managing climate change. And so there are 3 cities that I think help to illustrate how different this problem, this global energy challenge, looks depending on where you are in the world. So let's take Oslo. Oslo is a great example. Oslo is an incredibly rich place. Per capita income is about almost $120,000. They use a ton of energy. Their air is even cleaner than Spain's. Basically, there's no loss of life expectancy due to air pollution. And their projected damages at the end of the century are minus 9%. What does that mean? That means they're going to benefit from climate change. The higher temperatures are going to reduce the harsh winters, and they won't have very nasty summers because it's such a cool place. So Oslo's, what are they thinking about Norway? They're probably thinking like things are pretty good. Let's not mess this up. Let's take Beijing. Beijing is home to about 20 million people. It's obviously much wealthier than it was, but still certainly poor relative to Norway. They use a fair amount of energy. They're going to be, it looks to me, like pretty focused on continuing to reduce air pollution, and climate change, while important, will not, I don't think, be the first order concern there. Then we have Lahore. Lahore is home to 12.5 million people. GDP per capita is very low. They're consuming, uncomfortably low levels of electricity or energy use. They have horrible air pollution. and they're like in the bullseye for climate damages. They're projected to have losses that are about 14% of GDP by the end of the century. That's not cumulative, that's every single year. And so what is Lahore, Pakistan, going to be focused on? I think they're going to be focused on energy consumption today. And they're not, even though they're facing large climate damages, I think going to be very focused on spending a lot to reduce CO2 emissions. And so the nasty part of, one of the nasty features of climate change is that we're all depending on each other in some respects, yet it is all running through what I'm calling this global energy challenge. So what do we have available to us to solve this problem? I'm going to talk about, try to focus on the market failures that are causing us to face this challenging global energy, face the global energy challenge. Okay, so the first is, and now like thankfully I'm in the EU, so normally in the United States I can make this point very loudly and very clearly, but you guys do have carbon pricing, and so through the EU ETS, but just bear with me for a minute here. Here is the private costs. I just flipped that graph we saw earlier on its side. The private costs of producing a kilowatt hour of electricity from all these various sources. We saw this a minute ago. And I'm just going to point out, to foreshadow where we're going, where's nuclear? Okay, like nobody's building a nuclear plant in the United States of America. I don't think basically in the market economies, no one's really building a nuclear plant. It's more than twice as expensive. But what I'm going to do now is recognize, this is like economics 101, that if you're causing pollution, that's causing damages, and you shouldn't be allowed to do that. You should have to pay for that as a kind of a standard polluter pays principle. And so if you add it to these private costs of producing electricity, the air pollution costs, and then importantly, the carbon costs, the whole picture changes. And now the EU does not have a carbon price like this. This is using the damages associated with an additional ton to set the carbon price. But if you did, the whole picture changes. Natural gas looked like such a winner. No one would use natural gas. Coal looks like an enormous winner. Coal looked like something people were using. When you see those carbon damages, the climate damages, like no one's going to use coal. Nuclear, which was like a technology that is on its deathbed in the United States of America and in many other parts of the world, is now like in the money. The renewables with backups, even with the expensive batteries, are now basically in the money. So we could choose to set up our energy markets in a way that reflected the cost. Instead, we're choosing to face the environmental damages rather than face them at the pump or when we turn on the lights in our house. And if we did, we would have a very different setup. So solution one is to price the externalities, or cause polluters to pay for the pollution that they're causing. Obviously, the EU has made great progress on that. Its price, I believe, is 70 or 80 euros a ton. This is saying it should be about $200 a ton instead. Okay, yes, but globally, we're doing terribly. The average ton is being priced at about $6 across the world. Okay. A second solution is that people often don't have the information that they need to protect themselves or take advantage of opportunities to protect themselves or invest in things. So a core role for government is to provide people with the information that they might be missing, and that can lead to protecting themselves or organizing politically. I'm just going to borrow from some recent research of mine, which is people's willingness to pay to reduce air pollution in India. This is it. If you just take the average person and infer it from their behavior, if you actually gave them 2 minutes worth of information on the damages from air pollution, it goes up by a factor of 5. So I think there's a lot of opportunities for providing better information to people. Okay, then I'll point to innovation. And innovation is a terrific word because it means so many different things to so many different people. And I'm going to try and be a little more precise about the innovation that I think the world is lacking. So I'm going to start with technical innovation, which is probably the thing that you guys have in mind. And I'll just note, so why should government, taxpayers, you, subsidize innovation? And the answer is really simple, that particularly for basic forms of research, the kind that's often done at universities or national labs, is that the benefits of that innovation, people don't really know where they're going to go, and so they won't invest enough in it because they're not going to take account of the fact that some of it will spill over to some other firm, and so it's not profitable for them to do that. And so there's a very strong case for government or public support of innovation. In fact, some recent research suggests that the public returns, that is accounting for the benefits it provides to the people who didn't do the innovation, are 2.5 or almost 3 times as large. I'll just note, we've gotten really lucky. The solar, the colors don't match here, but the solar's yellow, wind is blue, and we've just had incredible reductions in the last dozen or 15 years in the price of them. But one thing I want you to pay attention to is the black line. That's the price of natural gas. There's also been remarkable innovation due to what we call in North America fracking or hydraulic fracturing that has greatly reduced the cost of natural gas. And so it's not enough that even with this amazing innovation in solar and wind, it wasn't enough. It's still, there was the people who run the oil and gas companies, as I said at the outset, are very smart, and they found ways to reduce the costs of recovering natural gas. There's been a lot of improvement in the cost of batteries, really remarkable in the last dozen years. But I want to just highlight that fracking came from accessing shale deposits. So what is shale's a layer of rock underneath the surface where the scientists or the engineers, the geologists knew there were lots of fossil fuels, oil and gas. And basically forever, or many decades, they were like, well, it's too thick and it's too hard to access, we'll never get to it. And so what the hydraulic fracturing revolution did is figure out how to get the natural gas out of there. And what I just want to point out is, to date, almost all of the successful hydraulic fracturing has occurred in North America. But if you look on that map, there's shale deposits all over the world. And so I'm pretty sure, like, all the North American companies are being hired to come to these places and figure out how to access it. And so the innovation we really need is remarkable, because we have this big ticking time bomb of all these shale deposits there. And it's not enough for there to be improvements in the low carbon technology. They got to beat the fossils. And I'll just say, I don't think the world is investing in basic R&D as if it recognized the importance of this. Okay, a second form of innovation, and I'll try and wrap up here, is policy innovation. And it's one thing for our policymakers and leaders to announce policies. It's a very another thing for those policies to have the intended effects. And I think just as there is a very strong case for technical innovation, supporting technical innovation, I think there's a strong case for supporting policy innovation. And it's kind of got the same flavor, which is, it's dangerous to try new policies if you're a politician, because it might not work and you might get blamed for it and you might get voted out of office. But yet, if you found something that worked and other jurisdictions could adopt it, that would be really beneficial for the world. And so I'm going to just tell you very briefly about one example of policy innovation that I was involved in. In the state of Gujarat in India, they had a terrible air pollution problem, or they have a terrible air pollution problem. And my co-authors and I suggested to them, why don't you try a cap and trade market this is for particulates air pollution. That might be an effective way at very low cost to reduce air pollution. And by the way, why don't you run it as a randomized control trial? And that is a graph meant to indicate the randomized control trial. Basically, they agreed, let's try it with 320 firms. They put the names of the firms in an urn and picked them out, and the red ones went into the treatment group, and they were regulated under a market or cap and trade like the EU ETS, and the gray ones continue to be regulated in a normal way. The results were kind of amazing. So first, you can see in the status quo, basically plants failed to comply with the rules all the time. The vertical red line is what all plants should have complied with. And you can see about 2/3 of them at any moment in time, only 2/3 of them at any moment in time were in compliance. In the market, everyone was in compliance. And it helps reflect the power of using markets and economic incentives. So that was result one, drastically improved compliance. The second is it greatly reduced air pollution emissions. The crosshatched are the treatment and the yellow is the control. And we had 10 compliance periods, basically reduced emissions by somewhere between 20 and 30%. And then in terms of economic costs, the market reduced the cost of achieving any level of pollution by about 10 to 12%. And so it was like a total win-win-win. The regulator was able to enforce the rules, people breathed cleaner air, and the firms benefited. And you actually had firms who were in the control group lobbying to get into the treatment group because they thought it was unfair that they were being denied the lower compliance costs. And if you were to add all this up in a cost-benefit analysis, the benefits of this market were about 200 times as large as the costs. Economists get very excited if something has benefits that are 1.2 times as large as the cost. And so this is like, a total and complete home run. And to illustrate the spillover component of it, the regulator was so excited by it, he moved all of the control plants into the market. He started a second market in the capital of Gujarat and Ahmedabad, and we're working with him to set up several other markets. The state has signed an MOU to help them develop a CO2 emissions market. Other states caught wind of it. The state of Maharashtra is now developing a sulfur dioxide trading program, and we're in discussions with several other states in India. And this is an example, like all from investing in innovation in one place, you can have much larger impacts. So I think, given how long I've gone, I'm going to skip this one, and let me just conclude where I started. And I was intentionally provocative in the title. I don't think climate change is the problem we have to deal with. I think the global energy challenge, of which climate change is a key component, is the problem we have to deal with. And that's because to improve human well-being, it's critical to find the right balance between these three goals of inexpensive and reliable energy, air pollution concentrations that don't cause us to lead unnecessarily short or unnecessarily sick lives, and avoiding disruptive climate change. So with that, thank you very much. It's a great honor to be here today.
So thank you so much for this amazing presentation, very provocative, very eye-opening. Now, because we have like about 10 minutes for questions, I'm going to open, for the floor for questions. Preguntas de la audiencia.
Professor Greenstone, this is your interpreter. Can you hear me? Professor Greenstone, if you can hear me, this is your interpreter. The question is in English.
I am Gustavo Barja, full professor of physiology, a biologist at Complutense University. I didn't have the luck you had to study one of the best in the world, Columbia, and Complutense is one of the worst because it is 100,000 students, so it's enough, you can imagine. But after my master's degree, I did studies with the Government of France in Paris, at UCLA during the PhD, then in the two best places in Europe, Zurich Polytechnic Institute, ETH, with Professor Christoph Richter, and with John Walker, the Nobel Prize winner in Cambridge University. And finally, I was a consultant for NIH, Bethesda, Maryland. So, after identifying myself, a comment and one question. My comment is, thank you very much for your excellent presentation. You changed my mind because everybody thinks about climate change. So you spoke about energy, and I am a physiologist. Energy is also important in the body. Body is much better than society. No pollution. But I want to ask you about a different thing. You spoke a little bit about politics. I am fascinated by videos just today, 13 hours in the European Parliament by Professor, for sure you know him, Jeffrey Sachs, who is full professor at Columbia University, precisely, formerly at Harvard University. And he's a brave man, and he says what he says about the trouble in our world, never seen since 1945, is not ideology, it's just in the archives. So I would like to hear your opinion, not about politics, but about the economic strength of Professor Sachs.
You want me to give Professor Sachs a grade?
Excuse me?
You want me to give Jeffrey Sachs a grade?
A grade?
A grade, yeah.
No, just to know your opinion about him. And what he says about Ukraine, Palestine, etc.
So what is he saying? He said that Sachs says?
Yeah, your opinion on...
Do you think he's a good economist or not?
I think he has a very distinguished career. He's covered many areas. I think his focus has not, in recent years, not really been on what I would call the global energy challenge.
Yeah,
so. But he's an incredibly accomplished and distinguished scholar who's made many, many important contributions.
¿Alguna otra pregunta? Any other questions?
Another question, please.
Greenstone for this talk. So my question is about the responsibility of the firms, because you talked about the emissions of the different countries, but I would like to see how changed the graph of the emissions of OECD countries if we compare it, for example, in terms of Scope 3 emissions of the firms. Thank you.
Yeah, look, it's easy and a favorite thing to pick on firms, but we're using their products. We buy their products. So I think it's not correct to pick on the firms. They would be happy, if we were willing to pay more for carbon-free energy, they would be certainly happy to supply it. And I think I'm not very optimistic about supply-side approaches. I think really the right thing is, let me pick on the return to the larger theme of the lecture. Like, energy consumption is not a problem. In fact, it's great. It does many great things for human beings. The problem is the kinds of energy that we're purchasing. And we should have incentives that guide people, let's call them carbon taxes, towards lower carbon sources, and then the companies will be happy to sell that to us. They're just responding to the rules of the road that we set.
Next question. You have one there, one there.
I don't want to sound naive. Of course, there's long histories of companies distorting information, but let's set that aside, although that should be dealt with in its own way.
Thank you very much for your talk. Very interesting and very direct. I have two questions, if I may. The first one, if I understood you well, you seem to be to rely on fracking as a good energy source for gas, natural gas, and the innovation process. But the ecological people think are against fracking for many reasons. What's your opinion on that? That's one question. And the other one, do you think the experiment you made in India, you and others, would work equally well in the developed countries? Thank you.
Okay, so let me start with that one. That one's easy. I think the second one. Developed countries have pollution markets. The EU ETS, the US has several pollution markets. By and large, they work quite well. I think the value add of that India study was to demonstrate that this regulatory tool that has worked so well and served Europe so well and served a lot of other countries so well can actually work in a developing country. And I think it offers a way out of those very severe pollution problems that a lot of developing countries are facing, be it either particulate matter conventional pollution or CO2. And so its real power is to demonstrate that this idea can work in emerging economy settings. Now, oh goodness, fracking. You asked me about fracking. Okay, so I'm going to put everything, I want to put everything in the context of these three goals. So fracking is terrific at producing low-cost energy. That's just a fact. But just as I don't think you should only focus on climate change, I don't think you should only focus on the private cost of producing the energy. It greatly increased the supply of fossil fuels, and so it definitely has, I would say, questionable climate impacts. It's been, in the US case, it's been very successful at knocking coal out of the electricity grid. But now we have like an endless supply, seemingly endless supply of a different fossil fuel. And so I think the right way to think about it is to think about its impacts on energy prices, greenhouse gas emissions, and air pollution. And let me say on air pollution, it's also been tremendous because natural gas is so clean relative to coal. So I kind of have a mixed view on it. Let me be completely academic and say I don't have a view. The data suggests a mixed view on it.
I have a question about carbon capture. Don't you think that a massive carbon capture could be a part of the solution?
Yeah.
This is one of the questions, and the other before I've been taken away of that. Is in your slides, there was not, in the energy slides, there was not hydraulic. No. So it's a minimum thing that doesn't
yeah. Okay, so let me take the hydro. I didn't put hydro on
Thank
there
you.
because hydro is very idiosyncratic. You can't build hydro everywhere. You have to have the water. But of course, hydro in some settings should be on that. I figure it depends where you're doing it. So I was kind of trying to characterize. The U.S. has hydro, but not everywhere because you need the water supply. Oh goodness, what was it? Oh yeah, carbon capture. Okay, so you could mean carbon dioxide removal from what's already been emitted in the atmosphere. I think you mean carbon capture coming out of the stack. Yeah, look, I'm for. So I'm going to return to one of my clear views on policy is we should be investing in R&D like crazy. We should be shooting money at the labs to try and figure this out. And we should figure out if we can get carbon capture to be economical. Right now it is not. But it is also true we have not really built out many examples, and maybe we'd get better at it, and it would prove to be less expensive than it is now. But right now, it's out of the money.
I think we're running out of time here because it's maybe one quick question, just one quick question, yeah, but make it quick, please. The gentleman there.
Yep, so with respect to the graph you showed about the social cost of the different energy sources, what would you say to those policymakers that on one side they focus on the reduction/prevention of the cost of climate change, but also they firmly reject the nuclear energy? This is the case, for example, in Spain.
So I didn't know that Spain is very anti-nuclear. Yeah.
This is debatable these days.
Yeah.
Yeah.
Nuclear is 20% in Spain? Okay. Look, I would again say all sources should be put across these three goals. The cost, the particulates, local air pollution impact, and the carbon content. Nuclear, I think does not do very well on the cost side, but does very on the private cost side, but does very well, of course, on air pollution and CO2. It's free of both of those pollutants. I would be a fool not to acknowledge that nuclear creates a sense of unease in people, and that has been a major impediment. What I will say, and is that the number of people who have died from air pollution from other sources, relative to the number of people who died in nuclear accidents, I don't know if the ratio is 10,000 to 1 or 100,000 to 1, or name up some absurdly large number. And so I don't want to take away people's lived experience and their feelings that nuclear could be this horrific thing. In the US, we think of 3 Mile Island and the example in Japan, and then of course Chernobyl. But if you were to become reptilian and just say, show me the numbers, the environmental costs of nuclear are tiny compared to the environmental costs at least from the fossil fuels. So it's not even a comparison.
Great. I think we're running out of time. That was the last question. Sorry. So thank you so much, Michael Greenstone. Please, un aplauso para.